I'll start with this post I saw on Stack Exchange last year, saying I'm not a DBA, but we have almost 350 servers. How can we monitor all of those? I thought that was pretty funny. I laughed pretty hard, and I may have blacked out a bit. But it made me think about being a DBA at scale and how it's different to being a DBA who doesn't work at scale. And you can't really blame this person because you can learn to be a DBA for a server or a cluster, but there's no real courses on how things work at scale. And it's quite different. And it's not just working 350 times harder than you do now. A lot of the responsibilities you have are very similar. In fact, anything you do as a DBA that you would do on a server irrespective of whatever application is on there is something that will probably work at scale. So you may roll out Hellengren backup scripts. You may roll out Hellengren backup maintenance jobs like index maintenance and stuff. You'll do something to monitor what jobs are running on the servers and whether they're failing or not. You apply the same patches. All of this stuff all works at scale. Security is a special one. At scale, you may not have time to look into what specific users have access to in databases, but you can kill a lot of other sysadmins. And you might think that's very easy to do, very fast. This is some of the paperwork it generates, though. This is mine up to 2015, because I killed a lot of sysadmins. One thing that doesn't go up to scale, though, is performance tuning. A normal DBA might have time to look into what's affecting an application on a specific server when it's having performance issues. At scale, you don't really have that kind of time. You have to do things a bit differently, which usually involves gathering performance information from all of your servers, ranking the worst ones out, and doing some right sizing. That's about as far as performance tuning goes. It's a lot, to use an analogy, being a normal DBA is a bit like a gardener because you can apply that kind of attention to one of the plants that you have, and if it's unhealthy, you can look at it. Whereas being a DBA at scale is more like a farmer, where if he was to focus on any specific plant in the picture, the rest of the farm is going to die. So the best a farmer can do is set up the rest of the farm and till the ground and fertilize it and such so that each server has the best chance of surviving on its own. And I think that's the right philosophy to have to be a DBA at scale. What this is really about is like a shift in mindset from anything you do to a single server, how can I use it to benefit all of the other servers in the farm? And when you do this, you start standardizing things kind of by accident. But I think that there is a really strong case for standardizing things purposefully as well. And this is where we'll get into some trouble with SQL Server consultants. Because a lot of the famous people will tell you, well, if you were to ask them, hey, what's the proper setting for this? The answer is always, it depends. I mean, it depends on your server configuration and your workload, and it's going to take a couple of weeks to test things out and find out what's going on, and meanwhile, they're getting paid by the week. But some people get it. This is a Twitter friend of mine, Lonnie, and last week he was talking about best practices and how using best practices minimizes your risk, and that it would be better to have servers that use best practices because you're more likely to encounter a problem that people know about versus not using best practices and having weird exotic problems. And if you switch a couple words over, he's almost talking about standardization rather than just best practices. Having things the same leads to well-known problems rather than exotic ones. But what happens if you don't standardize anything? Well, I'll be happy to tell you what your first day at a company with 350 servers will be. You will walk into the doors with 350 low memory false alarms because no one will have set the max server memory and B setting properly. What should it be set to? Well, we know that there are formulas to calculate it, but some consultants will say you should probably spend a lot of time looking into each server to find exactly what it should be, and you won't have time for that. And you have some backups, but without a real standardization strategy, you won't know where they are, and you won't know which servers are backed up. Most of the time, non-prod won't even be backed up, but the important thing is everyone expects them to be backed up. And you have a lot of maintenance plans set up, all built in the GUI, all with different checkboxes, all running at different times. You'll have servers going off at midnight because they're doing an index rebuild because someone ticked it in a maintenance plan, and all of the information about that is buried in an XML column in MSDB, and there'll be no way to know what's going on. Over 350 servers. If you're going to work at scale, standardization becomes a survival practice where you need to make some really big calls about what you want from your environment and make it happen to get the biggest value. Or as Trump will say, just do it, take action. Now, a SQL Server consultant will say, don't waste your time doing any standardization that's not going to provide you some business value. But I think that standardization does give you a kind of value. It reduces your risks, complexity, which is linked to support costs. It improves performance and reliability, safety, and golf time for your manager. Why do I think standardization is so important? Well, to explain that, I have to tell you about what I was doing a couple years ago. So I was a DBA really a developer for about 6 instances, running 100 databases, or client databases, that were all meant to be on the same schema, with some common data, running the same procedures, but it was all maintained by handwritten scripts, and also deployed and upgraded with handwritten scripts. And what I discovered when I tried to upgrade it to modern tooling, like Visual Studio database tools or SQL Server data tools today, was that nothing was the same. Everyone expected it to be the same, but they'd never actually gone to check that it was, and so it wasn't. So that's when I got into PowerShell. So I used some PowerShell to manage replication, roll it out across the servers, get the data into sync. Use PowerShell to pull in all of the database schemas and compare what tables were here, what tables were missing, and what columns were different. That was my first taste of things at scale, and I really liked it. But after that, I moved on to another company with 100 database servers, and I stopped caring about applications and thinking, how can I apply this kind of standardization philosophy to servers rather than applications? Well, I had the same plans, consolidate some information, start standardizing, then begin improving things. But the thing about working for a company with 100 database servers is there's always another 100 database servers they have that you didn't know about and will get dumped onto your lap. So halfway through standardizing my servers, I had a new 100 servers, which I had to somehow roll into everything I had done so far and then pick up where I left off. But the thing about working for a company with 200 database servers is that they actually have another 100 database servers you don't know about. So 6 months into my standardization, back to the beginning to standardize again, and again, and again, until I had 500 servers, and I still expect more. And this becomes really difficult to deal with. I mean, I know I was on the right path, consolidating information, analyzing it, improving all the servers by standardizing them, but it was a bit much to deal with. And then a horrible, horrible day happened where a data center went down at 2 a.m. and they said, hey, can you just check 500 servers right now and tell me if anything is wrong with them? And even me, with all of my PowerShell scripts and standardization, found that really difficult, although I did really well. So what it made me realize was I had these things. I had a lot of standards, and I had a lot of servers which met my standards. But I need a way to validate all the servers meet that standard at 2 o'clock in the morning. And my standards were here and there. They're in emails and notes and documents. I really needed a way to standardize my standards so I could do them all in the same way. And I needed a workflow for this so I could share the load of dealing with standards with my coworkers. And the closest thing that there is to this, there's nothing really in the infrastructure world. There's, for programming, we have test-driven development, and they have lots of cool things like DevOps and continuous integration, and you've got desired state control for infrastructure, but that's not for old servers, it's for new servers. But the closest is programming's test-driven development. So a programmer gets a requirement from a business, and they create like a dummy application. And then they'll write a test. The test will test whatever functionality has some inputs, they'll compare it to some outputs, and the test will fail the first time because they haven't actually done anything except for write a test. Then they'll write some code that is the original requirement, and their test will suddenly pass. but this doesn't quite fit into operations. How do we turn this into operations? Well, first we need to think about what makes operations go wrong. And we'll pick an example, something very simple like maxstop, where you think your max degree of parallelism is set right on your servers. Well, when did you last check? Because the longer it's been since you checked, the more likely you're going to be wrong. Why would you be wrong? Well, how many new servers have been built since then? Maybe the scripts that you use to provision those servers isn't setting maxstop properly, or maybe someone else set it up and never set maxstop. Or you've acquired another 100 servers from somewhere else, their maxstop might be wrong. Or software is often tweaking SQL Server settings now when you install it or upgrade it, and people just go on and change things. Although they shouldn't have permission, they still do it. Infrastructure could have modified the virtual machine config to increase the number of cores. Now your maxstop is wrong. And what formulas are you checking with? I mean, are you using the exact same formula every single time, going back to that very first server you checked until now? Could the maxstop setting have been reverted by a SQL patch? I haven't seen that happen, but SQL patches can revert other settings like your job agent history number. And if it's 2 a.m., can you validate that your maxstop is right if something awful happens? And if you didn't check today, how can you really say that your maxstop is right? And then when you do check, it's always, oops, I didn't know. Your standards only matter if you can validate them, and they're only as good as the last time you tested them. So you should be writing some way to test your validations, and they should be running all the time. So this is what our day-to-day workflow should be like. We have an expectation. That its maxstop doesn't matter. It can be anything that we think should be true. What matters is that we care that maxstop is set to something correct. So we're going to write a test to see, is maxstop what I think it should be, whatever that is? And it's going to fail. And what you'll find when you go through this process is you'll be 100,000% sure that your expectation is right and you're wasting your time. But when you go to do it, you will find servers at scale that don't meet it for one reason or another. And then you've got an excuse to start standardizing and say, well, I've got my formula, I've put in all my groundwork in my test, now it's time to fix it everywhere and test it again. And when it passes, keep testing it every day across all of your servers and occasionally fix the ones that pop up. The important thing is when the test does fail, you have some kind of method of notifying yourself that it has failed and you need to take action instead of silently rotting in the background. Well, there is another option here where you can write a test and it fails, and instead of standardizing it, you decide to throw your expectation into the trash bin. Why would you do that? Well, sometimes after you've written a test and seen how bad your environment is, then you have to fix it, and it turns out fixing some things is a bit of a nebulous area. Let's say you have an expectation that page life expectancy is correct on your servers, as in, it's above some threshold like 300. But of course that's from 20 years ago with servers which had a gig of memory, and now they have 200 gigs of memory, so there's some kind of factor there to turn PLE into a much higher number, and then it's split between your cores, and then your cores can have different PLE settings which are masking the overall PLE, and when your backups and maintenance run, your PLE drops to 0 anyway. So PLE as an expectation is something that you probably wouldn't write a test for, or you would start writing it and decide this is too hard and throw it away. And it's probably better for monitoring anyway. But that's a good thing, because once you start doing this, you build up a list of things that you know you don't know. Otherwise, someone comes to your desk and says PLE at a healthy value on our settings, and you can say, well, we don't check it. And why don't we check it? It's because of this massive list of things that I looked into, and we just have no way of doing that right now because there's more important things to do, otherwise the farm is going to die. But to contradict myself, once you have all your other test infrastructure in place and you've ticked off all of the important things you care about, now you can go back to PLE and think, how would I address this at scale? Maybe once you've standardized your backups and maintenance everywhere, you know what time of day it's going to be running, you can start consolidating all the information about PLE from your servers, and you'll have some spare time to write some R code to analyze what the worst servers in your environment are and start right-sizing them. And that sounds really exciting. That's, I think, what DBAs should be doing. The best thing about writing tests and automating them is that if you were to check PLE, you might just check it's above 300 because you've got a lot of servers to check and a lot of things to do. And that's an easy test to do to get done quickly and tick the box. If you write a test though, you could spend a couple days on it because it doesn't cost you anything to run it from that time on across all of your servers. So it's not really like an investment into fixing something properly that doesn't cost you anything anymore except for ongoing maintenance and perhaps improving it. If you improve a manual test that you have to type in into something complex, it's probably something you're not going to run properly every time versus running a test where all of it's written in there and you don't need to do anything extra to do the full run. So, the other benefit of this is when someone says, hey, is our max stop set properly? Of course it is, because I checked it. I mean, it's tested every day and validated against every server. It's something that you really own now. You prove it. If someone wants to know, you can point them at something and say, look, this is my validation that everything is correct. And if you're sick, if you're off, whatever, even if you're wrong, at least your test is there, having your back. So, what have we got so far? We have expectations that need to be validated, and you always should assume you're wrong because you almost always are. You should write some tests, and you should make them fail first, and then make them pass after you fix the test. The tests are only as good as you last run them, so run them often, and you should standardize things along the way because I said so. And this is a lot like being, well, the way DBAs work is a bit like a GP, where people come in all day and say, hey, I'm sick, fix something for me. Doing operational validation is more like being a World Health Organization, where you're identifying a problem or a disease, and then you're vaccinating your entire fleet for it and moving on to more important things. I think that's the more fun way to work. So that's a lot of talking. What are we actually going to do here? Well, I'm going to show you the software that we use for scheduling. I'll give you a way to integrate PowerShell with it, and I'll show you how to write PowerShell tests. And then we're going to go through the really cool bit, which are some tests you've probably never even thought of before, and it will be fun, or else. So what we're going to use is Jenkins. And if you do decide to start using Jenkins, I'll send out the slides later, but there's a link here to their security advisories forum where you sign up. And if there's any security issues, then they notify you about a week in advance and say, hey, a new patch is coming out. And you go into the UI and click the Upgrade Now button, and then you're fixed for that security problem. Because if you run this, then it is on your infrastructure. It does need access to things. And so you should be trying to keep it secure in any way you can. And when you go to the Jenkins website, it's actually quite hard to find what you're meant to do, because it's hidden behind a little drop down here to say, I want to download the Windows version. And it's split into two kinds of release. An LTS release, which is a snapshot that lasts 8 weeks and doesn't change much, so you don't need to upgrade things and it's more stable, or a weekly release, which is more cutting edge things. But really, I haven't seen any failures from weekly releases, so whichever one you pick will be fine. When you run the installer, it's just like click, 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 next, done. What it does is it copies the 32-bit Java runtime to a folder here, and if you do a lot of work with it, you can install a 64-bit Java runtime and change an XML file, and it will start using it. The other thing is it installs as a service running as local system, which probably isn't great for security for something that occasionally has security issues, which they take very seriously, but it's still hard to justify. So, create a domain user. All you need to do is give them access to the Jenkins directory. You change the service to use it, and you run this command so that any owner of that account can stop and restart the service for the purpose of applying the updates and upgrades. And then Jenkins will be running. And I've already installed it in my VM, but if you go to, if it creates a port 8080 on your local machine, and it asks you to log in, you don't have a login yet, so it's got a file in the file system, and then it asks you to deal with plugins. Now Jenkins is about 10% of something, and the other 90% are a massive list of thousands of different plugins you can install on it to do lots of cool things. They have a list of suggested plugins, which is great for developers, and maybe not so great for us, but you can use it. The only thing is it installs a lot of junk you don't need, and then when you go to update things, you have to, there's a big list of things to update. If you want to do just some selected plugins, then I have a slide here that's got the plugins you can remove because we won't be using them, and the ones that you'll add. Active Directory gives you Active Directory integration for your users. XUnit, which we use in our tests. A dashboard, which is something that looks cool. And Windows Slaves is something we won't be using today, but it lets you install Jenkins on multiple servers and farm out the workloads for really massive scale work. But you probably won't need it, because even a server with a couple cores is enough to handle 1,000 servers or so. So after the plugins are installed, it just asks you to create a dummy account, and you're in. Now, this is what you will see for the very first time you log in. It looks pretty blank. I have already enabled Active Directory integration, so I want to show you where you set it up. On the front page, there's a Manage Jenkins button, and here in Security is where you go to turn off its internal security and turn on Active Directory integration. So it will be here on Jenkins' own user database. You change it to Active Directory. Matrix-based security, just because, and you add in your username, which will be case sensitive based on your domain, and we'll add an entry here and just grant yourself access to everything because you're you and you trust you. And then you save it and log back in, and you'll be at the same state that I'm in. But there's another step we have to do. This is where the plugins are, and there are some additional plugins that it doesn't prompt you to install. There's the PowerShell plugin, Test Results Analyzer, green balls because by default success is marked blue for some reason, and there's also another plugin here that I find really useful for development. And the way you install these is you go to the available section here, and you just start typing PowerShell, but I already have it installed, so it's in the Installed tab. But you just pick out the couple that you want from the list here, you tick the box, and there's an install button down here. So it's pretty easy to get going, don't be intimidated by it. So that's all pretty nothing. Let's create a test. Well, here in Jenkins, tests are also called jobs, which are also called projects, I mean for our purposes. So let's create a simple one. It's always a freestyle project. The other ones are for other things. And that's it. So we've just built a test. We won't do anything else. We just save it. Back to our main screen. There is our test. I can click on it to go into the details of it. There's nothing here yet. Build now means run my test. And you can see the pop-up down here that it passed. It records all the console output of everything that runs. So that's useful for debugging things. And also keeps some statistics on when they ran, how long it took, things like that. This isn't very useful, so let's make it useful. We add a build step, which is PowerShell. For most of your tests, if not all of them, you'll just have one PowerShell build in here where you enter your commands. So let's just say hi, and then we'll build again. There's our output hi, and it passed. How would we make a test fail? Well, you could try write error, but that actually isn't enough for this specific plugin that Jenkins uses. What it wants to see is a global last exit code. If that's set to 1, or something other than 0, then it will fail the test. Okay, so we have our write error here, and then we have our failure condition, and we have a red ball. This doesn't look very interesting though. I mean, there's nothing really here. That's on purpose. We need to do a little more work. But before we do that, let's talk about some troubleshooting for the first time you use this. If you have it on a server's account, there's a PS module path in its environment, which could be different to what you're expecting. There's different paths for x86 and x64, so you need to make sure that whatever you're doing is valid for whatever path you have. In PowerShell 5, there's an install module command you use to download modules from the internet and install them, which I'll show you later, but that has to be run in each environment, 86 and 64, depending on whatever Jenkins is using. And remembering Jenkins is by default is the 86. And if you need to use specific modules that you've written, you just put an import module at the top. So the reason we're not getting anything from Jenkins at the moment is because that last error code just passes or fails the test, but it really wants some proper XML to tell it what happened. And a good one to use is JUnit XML. And this is how it's structured, where we have a suite of tests. We have a specific test class that happens, and then we're testing a specific thing like a server. And if it fails, there's an extra fail message and some fail data. Or we might skip a test, and it will also have its own little skipped section. So let's put some of this to work. What I did was I wrote a function which will take a PowerShell object and turn it into the XML that Jenkins wants. And you won't be writing this. This is just to demonstrate what Jenkins will look like when it's got some proper data. So what I've done here is it's just a hash table object with my property names and some values, and this is the standard I picked on that represents what's in JUnit, and then I call my function, which writes it out to a file called jojoba.xml, and then we set a success. There's one other step we have to do here, because we have to tell Jenkins, to look at our XML file. Don't use the published JUnit test report, use XUnit, which is a module that we installed earlier. You add a JUnit file to it. You say it's going to be called jojoba, and that's it. Let's build it. And I really hope this works. Okay, so we got a pass. In the PowerShell I just wrote, I just dumped out what was in that jojoba.xml, and we have this XML snippet here, which looks like the JUnit thing I showed you earlier. But the important thing is that we have this extra bit here in Jenkins, where it can interpret the test result and say, hey, okay, you've got a suite, you've got a class here, and you've got a test case here, and it was all okay. That's kind of useful. Let's take it one step further and add some more detail to this. Let's add a fail test. So I'll just add another object here. And we'll call it C1 and 2, and we'll fail. And you won't be writing this by hand, it's just for the demo. Just for the demo. And something else. Let's build this again. And we're going to get something really useful this time. Now we can see that there's a test that failed. And when we click through, it will show us the test up here. It'll tell us what failed, why it failed, and it'll have some extra data here that we can pipe in. If you want to see all the tests, we can still click through below that and see which test passed and failed. But also, this is a plugin I installed earlier, Test Results Analyzer, which starts giving you graphs of the test results, and you can expand to see better what passed and failed when, and get statistics from it. So that is more useful. Maybe we can do something with that. But let's take a sidestep for a moment. If you're doing things at scale, you need to do it across a lot of servers at once. Now PowerShell has its own system for managing jobs, like for spawning out some tasks that you want to do, start, wait, receive, remove job. But they're very resource intensive. There's an alternative, which is a module, POSH-RS job, and almost everyone uses it, and it has very similar named commands, start, wait, receive, remove. and that's what we'll be using. Why would we do that though? Well, the first command here, and I'm not going to demo this because it's straightforward, is we're going to do 20 sleeps for 1 second, which will take 20 seconds. On the second one though, we're going to use the job system, and that will spawn up a PowerShell process for every single job, which uses a lot of memory, and it tries to run them all at exactly the same time, which is really bad. And the last one is how you would run things with PostRS job, and it's very, very similar. It sets a throttle of 4, saying we're going to run it across 4 cores at the same time, and it uses very little memory. And you'll find the more that you put through this, the faster and faster the bottom method will be. But that's pretty painful, because those are pretty long commands to type every time you want to test or do something. And so I had an idea. This was end of last year, so this is a bit out of date now. But it was to write a function template that would automatically run workloads in parallel using PostRS job. So when you call test something, it takes this input object, which is a string like a server name or a SQL Server name or a URL, anything. It'll come down to here and run PostRS job to spin up a session for every single string that it gets in. And then when those run, it will go down here and do the work. And at the very end, the master process will start waiting for everything to finish and receive the results. So that's a pretty complex bit of code. That's where things started, but there's other problems, which is errors. And this one I am going to demonstrate, because when you're running things in parallel like that, how do you find out what went wrong? Here I'm going to start 10 jobs, and one of them randomly, well, not randomly, it's going to be number 5. I'm going to write an error out, and we'll just see what happens. So, yeah, 1, 2, 3, 4 is fine. Then I've got an oops, 6, 7, 8, 9, 10. How do I tell that the oops was one of my servers? That is a difficult problem. And you can start trying to get around it by giving each job the name of the server it's going to work on, and then doing some complex stuff at the end to associate the results output with the name of the job. And it kind of, things start getting swallowed up, and it's hard to read, and you're not going to be just returning numbers, you're going to be returning really complex results about what just happened, and it becomes impossible to manage. But if you think about it, that JUnit XML format I showed you before is a really logical way of representing whether jobs worked or failed and why. So we could set up a system where we have modules, which will be suites, we have functions, which will be our tests, and in JUnit they're called class names. In JUnit it calls a case name something. We'll use like a server, instance, URL, whatever. We pass, fail, or skip each job, and we give it a message and maybe some data. So I wrote this module called jojoba. It's a PowerShell module. It's on GitHub, and I'll also show you how to install it, because it's just a one-liner. And it has this idea. So every test that we write should go automatically parallel, because I have the code for that. Every test that we write should return in that JUnit XML format, and it should be in a way that encapsulates any possible error that could happen, so that we don't have to go looking for it. We can just look for the pass and fail without having to filter out those red bits that we saw before. But also, I mean, we can't just read XML on our screens. We should be able to run things interactively. So we should also output it to the screen in a readable way, and then output to XML for Jenkins. And this is what I came up with, which is even less than before because it's using my jojoba module. So if you were to write a test, all you do is change, well, actually, I did one here. So we would change the name of the test. So instead of test templates, test computer ping. On our input object, we'll just give it a friendly alias. So when you call it, you can say test computer ping, computer name, and whatever the computer is, rather than calling it input object. But we call it input object here as part of the template because that keeps it standard and lets all the magic happen. Then in the process block, we have our actual test, where I'm going to output what has been input into the test, and then test it with testnet connection or any other commandlet that you want. And then I'll call a special function called WRITE-JOJOBA fail with a message. And that's it. Everything else is exactly from the template, and you'll find that this can cover most every testing situation you can ever think of. So, how would you start using this? Well, remember I said before that Jenkins runs a 64-bit. So if we have an x86 PowerShell environment here, and I'm using PowerShell 5, and actually we're up to 5.1 now, and you should be able to install that on pretty much any workstation you have. What you would do, once it loads up, I've got some custom extensions. But PowerShell 5 has a thing called install module. And you'll say install module jojoba, and it will just do it for you if you run it as admin. But I do already have it installed here as well. Now, we need to start creating a PowerShell module for ourselves. So, I have in my PS module path my folder here, Git, and I'm going to start creating a module. And if you've never created a module before, this is how you do it. New module manifest, path, pssvg.psd1, the D is for definition. And I do have this, but I wanted to show you so that you have something to refer back to if you forget how it works. So, root module, required module. So we need to uncomment root module here. This is all standard PowerShell stuff. The M is for module. There's a required modules here, which will be jojoba, and functions to export. This here will be test computer ping, because that's a function that we're going to create in there. There's one more bit. Which is this file here. All it does, because I didn't want to type it in, is just this bit here, which gets any functions we put into the folder and loads it into the module. That's pretty standard across all modules. I just have my own one. So, now I'm ready to go. Let me take what I showed you before. Test computer ping. Save it. Okay, now let's test something. Hopefully it will just work. There we go. So on this demo environment, I've got a 3-node availability group cluster, C1, N1, N2, and N3. So what I've done here is just test against C1, but of course I can run it across all of the nodes at once, and it will be running in parallel in the background. And it's not super impressive with just 3 of them, but once you get up to dozens or 100 and the tests take a really long time to run, it has some real benefits. But we're not here for this. What we want to do is put it into Jenkins. So let's do that. Let's take this and let's rename it to test computer ping. Get rid of all of this. Yep, all of it. There's one more option to put at the end, which is jojoba Jenkins, which tells it to write out that XML file. Let's build it and see what happens. I should have added one more in to fail on purpose. Let's do that. Can still do it while it's running. There is no C1N4. That 6 there is the test that I just ran. what it does is it works out how long the last test ran and uses that to calculate how far this one should be through. So you get a kind of progress indicator. Okay, so my script here ran fine, and we can see pass, pass, fail. Then here in Jenkins, we have our fail here, and it tells me C1N4 failed, blah, 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 and will also be in our test results analyzer. So this is the beginning, this is the old name of it. This is the name of the module, this is the name of the function, and here's the 3 tests here. Don't remember why I've got that suite there. I think that's from one of the previous runs. So that's kind of useful. Done that. There is one more other thing you can do with it though. The way it's structured is, if you create a more complex object and pass it in, and you have a property on there that's computer name that's aliased to that input object, then the test runs exactly as normal, except you can output all of the rest of your complex object within the test. Why is that important? Because when this test fails, if you have this information in your inventory and can pass it in, however you do your inventory of SQL databases, when you see this test failure pop up in Jenkins, this will be in that stack trace section, and you can, without looking up any further, you can go, oh, this computer is in this category, this location, and that becomes useful later on once you really flesh out how you store your SQL Server information. So before we go further, there's some special things you need to do when you're running PowerShell in parallel. There's WMI versus SIM. Now, if you've ever used WMI, it's pretty basic. It's used to get a whole bunch of information from Windows, and you will be used to seeing it in scripts like this, where you get WMI object, the computer name, some class, and it returns you a bunch of data. Thing is, this can hang, and if you run it against hundreds of servers, it almost certainly will hang, and your test will never return because WMI is almost always broken somewhere. So there's a different thing for PowerShell 3 and above, just on your workstation, not on the receiving servers, called new sim session and get sim instance. And so instead of using get WMI object, anywhere you see it where it's suggested, you replace it for, where are we? You replace it for these two. So the sim session is making a connection, and then this one is pulling back that same WMI information. And the important thing is you always give it a timeout figure here. So it will always return no matter what. But it has one problem, which is the default get sim instance doesn't work if the destination server is below 2008. So what you do, it's this thing that doesn't work on 2008, unless you write a whole bunch of wrapper code to deal with it, which I did. So when you go to use this, you go install module sim session, which will download my module, and then instead of anywhere you see new sim session, you use new sim session down, and it works across all of the servers you have, even 2003. But the second problem is invoke SQL command, because everyone who uses PowerShell in SQL Server will know this. It's in the SQL PS module, which is what it used to be called when it's bundled with SQL Server. The SQL Server module here is the one that's included with Management Studio when you download it. Anyway, it's pretty straightforward. Invoke SQL command. I've got a server here I'm going to query against, and my query. Okay, it runs 100 times, no problem. What happens when I try to run this in parallel? Well, I'll show you exactly what happens. Here's it running 100 times, and that's all the issues it has, because Microsoft doesn't write their code properly to work at scale. So, also when you get home, you can install my module I used to get around all of this, called DBDATA. It's a lot like SQL command, but it doesn't fail when you do things at scale. There it just ran 100 times without any errors. How do you use it? It's a 3 commandlets that you use over and over. You start a connection to a server and a database, you have your command, and you get the data. It's so straightforward, but Microsoft can't get it right for some reason. There's another problem with invoke SQL command though. Everywhere you see it used, it accepts parameters now, where it does like a SQL CMD substitution in Management Studio, which is also open to injection attacks. So here I've passed some parameters, and I'm going to get also the minimum name of a database, and that's a database on my server, which is probably not what was intended by whoever wrote this query. In DBDATA, you can do the same thing, but you won't get hacked. So here I've got a hash table with a property name and whatever I want to pass in, property name, where I attempt to hack it in, and then I start my connection to a server. I have my command. I tell it, hey, these are the parameters. Those are the variables named after the properties I used, and I get the data, and I don't get hacked. There are some good things about invoke SQL CMD. Well, actually, it's another function that comes with the SQL Server module, and it can take a whole bunch of data and bulk copy it into a table on a server, and it can also create a table with a whole bunch of nvarchar max columns and no primary key or identity. And that's fine because I don't do that. But what DBDATA can do, we can start a connection, we can start a command to get stuff from their table, and we get it as a table. Now, our table has a special alter object where we can pass in a hash table, which will either insert or upsert records based on what's happening inside the table, and then later on we can go and delete data that we don't want in the table anymore. And there is nothing like this in the SQL Server PowerShell modules. We can do other stuff with DBDATA, I won't go into it. You can do bulk copies, retries on deadlocks and timeouts when you select data and stuff. I've got transactions in there, and the other thing is you can get SMO objects, which we're going to be using in the demonstration today. So, no, where's my caps lock? Get dbsmo, C1N1. So if you've never used SQL management objects before, Management Studio uses them. There's .NET libraries that give you all the information about your server and are really cool. You'll see that in just a second. So there's like all the properties just pulled back from my server about what service accounts are in use, what databases I have on there. And you can see if you're in ISC, then all this stuff will auto-complete. So you're safe to go splunking around to find what you want. So that's what you start doing, which is a lot. It's a lot to take in. So what's your daily workflow going to be? A problem's going to happen. You ask, what's the expectation I have? And how can I test this in the future? You use it as an opportunity to start standardizing your servers. You write the test before you fix anything. Confirm the test passes, then you add it to Jenkins, and you move on to more important things. So we're going to start. Let's pick 5 tests, and these go from easy to hard, and from well documented by Microsoft to not documented by Microsoft at all, and not supported in any way, shape, or form, but just stuff that I found over scale. Who would create an availability group, but then forget to put a database into it? Well, you'll find that something can go wrong. It could just drop out. Someone could actually forget to add it in, or they could remove it temporarily and never put it back. So let's test for that kind of condition, because I do have an availability group here. So test database availability. Geez, I hope that's spelled right, otherwise I'll be really embarrassed. So I've written the test here. So I use my getDBSmo from before. I check whether HADR is enabled, which is that tick box in the SQL Server set configuration. And I check whether there's any availability groups as well, because people can enable that HADR, but not enable this. Also, if you do this on a 2008 server, it's fine. If you do this on a 2008 server, your test will fail because those don't exist on 2008 servers. So if it's enabled, we've got availability groups. Let's go through each database. Let's check it's not one of the system databases because we don't care about those. And check whether it has an availability group name. And if it doesn't, then let's fail. Right, fail. I'm going to save this into my module. Now, I'm pretty positive it's going to work, so I'm going to add it to Jenkins. So, what do we call it? Availability group, freestyle. Then we add a build step, which is our PowerShell. We import a module. Now, we're not just going to be typing our server names each time. There is another PowerShell module called DBA tools. So when you get home, you install module DBA tools. And it has a whole bunch of stuff in it that will simplify things if you're not quite sure how to do something. Here in particular, there's one called Get SQL Registered Server Name. And what it does is it connects to whatever server you specify and gets back the list of servers that are in the registered server list. You know, the one that's up here. Central management servers, all those. So that we don't have to edit our jobs over and over, just pipe that into my availability group thing. And you could replace this with whatever inventory system you have. So it's just going to get all the server names. Oh, I forgot to do something. Got to add the post build step, X unit, J unit, jojoba. Naturally, I don't think I've installed DBA tools into our x86 thing, so I'll take back what I said about that and just use server names. To save time, rather than installing it now. And I need to get rid of it because it's not there. Oh, and there's one more thing to do, which is in my module here. I have my test computer ping. Now I add test data. You can actually put a star here, but you'll find actually listing them out makes PowerShell sometimes discover it even if you forget to do the import module. So fingers crossed, it's taking longer this time. And I'm using the SQL Server module. So oh, why? Because I'm running this under a service account and I haven't given it access to the server. And let's just give it sysadmin. Oh, oops. Neither did I. Server. Come on, work with me here. Wonder if that will be a problem for later tests. I think so. Oh no. Huh? Yeah. One Powerball and I'm out of here. Oh, okay, so close now. I need to tell it to write the XML file. Jenkins. And I've actually worked out a way to get around that, so that's not going to be required when I get home and publish a new version of the module. Green! Okay, so here we have our test result, and surprise, surprise, I've forgotten to put one of my databases into my availability group. So I was going to go through and just add it and show you the test passes, but let's move on. So there's another issue, suspect pages. Actually, I think I'm not going to go through all of these. I'll just show you what the test will look like. For suspect pages, we can do a select from the suspect pages table. If anything gets returned, then we can make our test fail. But while we're doing that, we should probably also check whether our databases have a page verifier checksum. Otherwise, it won't start populating the suspect pages table when anything is wrong. So that's the kind of test that we would do. How about listener redirection? Because when you create an availability group, it doesn't automatically do read-only routing to other destinations. So how would that look? Well, this is the test here, so don't get too scared by it. But all we do is we go through each availability group. I would also do the test here to see whether HADR is enabled and whether there's any availability groups in the first place. You get the first listener and port number. You pick a database from it. I'm using with DBDATA here to connect to that listener twice, but with a different application intent. And my command is to get the server name, and then compare whether the server names are the same. And if they are the same, then something is wrong. And here I've got the commands I was going to use to show you how to set it up properly, but we won't have time for that. So this is a two-parter. How do you know that your availability group nodes are all in the same version? Because it's not going to tell you itself. So I wrote a test here that gets your availability groups, finds all the replicas, connects to each one, gets the version from the first server you passed in, and compares it to the version of this replica, and then fails if they don't match. But it gets more complicated than that, and this is why it's right at the end, because it's a really complicated test to do, because that kind of thing will not work for failover clusters. For failover clusters, the other nodes will not be running at the time, so you can't check what version they are. So how would you deal with it? Well, you can work out what the instance name would be, so all the instance name for your clusters has to be the same. And I've wrote a little function here where it will use the sim stuff to work out what path the SQL Server executable is and what version the executable is. And then it will connect to the main server, work out each node's version, and then tell you whether the nodes are different versions or not. Oh. Oh, it's meant to play a sound. Yes. Okay. So this is like a real amazing one. Those are my notes. Ignore those. What I found was, because I apply a lot of SQL Server patches, maybe 4,000 in the past year, and I'm not sure if you've ever run the SQL Server setup, but when you go to run the patch version of it, it will sometimes say that one of your components hasn't been fully upgraded, which means that something bad happened while the patch was being applied, and it often never gets identified or fixed until you go to apply the next patch. This one, I think I want to show you what it looks like. So let's try this again. I don't think anyone else in the world has this test. Test, we'll just call it computer upgrade because it works on a computer. We'll add a build step. Oh, not that one. Add the PowerShell step. Let's try to get them all this time. SSUG, SQL Server, just in case. And the rest should just be fine. And I'll give you some detail about how that works in a minute. I'm going to publish it. Add this, JOJOBAXML, and that's not what I want. Oops, I missed a step. This is all meant to go into a function. So, new function, test computer upgrade. It's my demo code. I think it's messed up the indentation. Okay, that's all okay. Whew. Let's see whether my test cluster is okay or not. No. Oh, and add it to the list here. I was really hoping that would just work first time. I sure could use it. Oh, and I've run into a problem because I haven't given my Jenkins user access to those servers. So, unfortunately, I will abandon this one and just run it interactively so you can see what it would look like. Surprise, surprise. This is my first test on my first node, which passed. This is all just debug data I write out because sometimes it's useful. In Jenkins, you don't see it for passes. There's my second node, which passed. On my third node, oh, my third node passed as well. Pass, pass. Ah. Here, I forgot to set this. Let's try this again. On my second node, now that I've fixed up my test, which is why it's important to test your test fail before you fix anything, I pulled the plug on it when it was installing SQL Server, and it has failed the test because the way I think that the patch update process works is it looks at these registry keys in this path, and there'll be a whole bunch of, I may even have it open here. There'll be a whole bunch of items here, and lots of them will have configuration state and upgrade incomplete. And through testing across hundreds of servers, I found that the upgrades are incomplete if this isn't 0 or if this is 4. In fact, this is a special one where you may not have seen it, but if you have reporting services installed, but it's not configured, patches will often fail to run. And this is like an indicator for it. So if I'd given my service account access to my servers and I could have put it into Jenkins, it would have been cool. But anyway, and the PowerShell code to do this is quite complicated. and I wouldn't expect you to get it straight away, but this is kind of the end result, where you patch hundreds of servers, and afterwards you can test whether there's any weird issue on them where patching didn't run properly. So let's say that that's not enough. You need some ideas for other things to test. Well, there's a call pending reboot script here on TechNet Gallery. Picking up pending reboots is important for SQL Server because it can often cause the .NET CLR to fail to load. You could check for whether Kerberos is working on your SQL Server instance and the listeners by connecting and querying your SPID on the DMExec connections. You could do some testing to see reverse DNS is working or not. You could also even test the SQL Server name is what you expect it to be. You can check whether your system tracers are running, like the default trace and extended event health sessions. You should install that DBA tools that I showed earlier because it's got a whole bunch of its own tests in there. And SentryOne also publishes the tests that they use within their software, and you can often take those and build it into something that will work in PowerShell. Now, the bad news about all of this is that it really opens your eyes to what's wrong with your environment. Once you have 10 tests, 20 tests, 30 tests, once you find over and over that your expectations are wrong, you start finding other people's expectations are wrong, but they don't know it because they don't validate it. And telling people that they're wrong when you've got proof of it is, people get tired of it. And it's kind of the downside of doing this. Your eyes are opened, but once you start using it, you probably want to open other people's eyes too. Otherwise, you will go insane a bit. And what if you only have one server? Well, it's probably what you think your server is like, and that's probably what your server is really like. You still need to do testing even if you have one server, because at scale, if one server out of 500 goes down, it's not a big deal. For you, it's an even bigger deal. So whenever you fix something or change something, you should probably write a test to confirm it stays that way. If you're interested in how this kind of philosophy and technology continues, I registered this domain name, operationalvalidation.com, which redirects to my blog, where I blog all of the time about SQL Server topics, and also post pictures of spiders. And I've got a link to my GitHub there, which has the source code for the modules, although you will probably just install it through install module. And that's it. All done. Any questions?
How easy is it to recreate
as far as I know, you can install it, like reinstall the executable, and then copy the directory back over again.
So that includes the text documents?
Yeah, like it's all stored in text files in that directory. So yeah, it's pretty straightforward to copy to other environments. But as you progress with this, there are other things you can do rather than creating all those jobs the way that we did. It has its own scripting language, so you can create a job which will read in all the functions from your module, for example, and create jobs based off of those. And because your incoming server list is always the same, it will just create all jobs at a standard format. And there's also a scheduling functionality, which I didn't show, but and this is exactly what you would do. You have a build trigger, build periodically, and there's a description here about the formatting for it. So, you can set it to run once a day or spread them out over a day. And there's also modules to email you when things fail. But most times you probably just use the dashboard. Whew, that's quite a lot.
I have a question. With 500 servers, how many of the jobs are
No comment. Lot more than I can fix. But the important thing is you know what is broken, and no one expects you to go fix it all immediately. I mean, most people don't have the luxury of even knowing what's wrong in their environment. Once you set it up, we're actually kind of privileged in a way. But yeah, I recommend getting into it. I mean, I think when I said on the session that you probably don't need much PowerShell, I may be a little wrong, but the test cases, they're the simple ones. I mean, things like this, you can get started, and once you get started, it's hard to stop. There was something else I had in the demo, which, and this was really stupid, but Didn't? No? Ouch. Okay.
Test computer ping on C1N1. Pass.
So yeah, there's a function there you can output to that will talk about the test results to you. Maybe you wouldn't use this normally. Also, if you're a remote desktop to the server and you're using the Jenkins interface and you have that in the command line, it'll read it out through the RDP speaker, which is just a Windows thing. It's nothing special I've done. But if you were doing something interactively that depended on a lot of tests, then it can be useful to use that on the failing test so that it kind of gets your attention that, hey, you're running this against 500 servers. Maybe some of your tests will take a long time. Most of these, across 500 servers and on a 4-core Jenkins installation, will complete in like 30 seconds. But some of them could take an hour if it's like a really complex test or you've got a lot of network latency and stuff. But yeah, it could be useful for that. So you can go get a coffee or whatever and have it trigger your Bluetooth headset or something else. Okay, all done. Go try it.